All right. Hello, everybody. Let's go ahead and let's get this started. Welcome, everybody, to the Divide and Conquer Challenge webinar. So today, this webinar is going to cover a few things. So I'll start by giving everyone an introduction to freelancer.com. From there, the reclamation team will give us the challenge background, as well as more information about the requested outcome. Then I will walk everyone through the challenge schedule and how to participate in this challenge, and also discuss eligibility. And then we'll close off with some live questions and answers. Before we get started, I wanted to introduce myself and some of the speakers today. So first of all, my name is David and I work on the freelancer.com enterprise team, and I'll be your host for today. From the Bureau of Reclamation, we have Yong Lai as well as Ben Aban, who'll be taking us through the challenge background and the requested outcomes. More about them in a bit. A couple things before we get started. This call is being recorded, and the call link will be made available through the challenge page. So make sure you can always refer back to it at any time. What that also means is if you have friends or colleagues who couldn't make it, I will be sending out the recording via email. And as long as they've registered for the webinar, they will get that link. Also, please use the Q&A panel today for any questions that you have when you have them, okay? So we have a dedicated portion of this webinar for questions, so make sure you make use of that. And don't put the questions in the chat, make sure you use the Q&A panel. Lastly, if we can't get to your question today, we'll make sure to answer them through an FAQs document that will be attached to the challenge page. To start off, let me tell you a little bit about freelancer.com. Now, this challenge is being hosted on freelancer.com, and so you will have to go through the platform in order to enter into the challenge. So what is freelancer.com? Freelancer.com is the world's largest freelancing and crowdsourcing marketplace by number of users and jobs posted. So to date, we have over 54 million users globally and over $4.5 billion in jobs that have been posted. When we talk about this connecting of users globally, we truly mean it. So this is a map of our users plotted in white on a black canvas. Pink is where work is being posted. Blue is typically where work is being done. So we see that connection there. Freelancer.com's challenge platform is what we'll be discussing today. Freelancer.com's challenge platform allows participants from all over the world to submit entries that a challenge holder can then choose from. To date, there have been over $1.5 million in challenge posted and millions of dollars paid out in prizes. Which brings me to the challenge today and the reason that everybody is here, cash prizes, right? So we'll be hearing from Yong and Ben about the challenge background and requested outcomes soon, but here's what's at stake. Here's what's available to you guys. Okay, so this contest offers a total prize purse of $300,000 split into two phases. The first phase has a total purse of $100,000 with the best solution winning $40,000. Second place winning $25,000, third place $20,000, and fourth place $15,000. The second phase has a total purse of an additional $200,000 with the best solution winning $115,000 and a runner-up winning $85,000. Note that only submissions that meet the challenge and eligibility requirements will be eligible for these awards. So as you can see, there's a whole lot of cash up for grabs for this challenge. And so with that, it is my pleasure to introduce to you all Yong Lai and Ben Aban, who will be taking us through the challenge background and the requested outcomes and how you can potentially win your share in these prizes. So a little bit about Yong and Ben just to introduce them to you guys. So first up, we have Yong. Yong Lai is a specialist hydraulics engineer at the Technical Service Center of the U.S. Bureau of Reclamation in Denver, Colorado. Dr. Lai obtained his PhD in 1990 from Arizona State University and has since been involved in a wide range of research, development, and engineering projects. Dr. Lai has published more than 60 scientific journal papers and numerous conference papers in diverse engineering areas. He's the lead author of the 2D flow and sediment transport model, SRH 2D, and the 3D CFD model, U2RANS. Dr. Lai currently serves as an associate editor of the ASCE Journal of Hydraulic Engineer and is a member of the Scientific Advisory Board for several conferences, and he regularly provides short courses on hydraulic and sediment modeling. We also have Ben. Benjamin Bond is a hydraulics engineer with the Bureau of Reclamation's Technical Service Center in Denver, Colorado. He holds a PhD in water resource engineering from the University of Tennessee, Knoxville, and is a fellow of NSF's Geoinformatics for Environmental and Energy Modeling and Prediction program. He's been involved in the development of several hydraulic and hydrologic models since 2007 and is currently a co-developer of the SRH2D and SRHW models, working primarily on extensions to incorporate hydrologic and hydraulic processes in terrestrial, in-stream, and groundwater domains. Yong and Ben, you have the virtual stage.
Yeah, hi, everyone. Welcome to this webinar. And yeah, I will hopefully quickly go through the background and expected outcome for this prize competition. Next. Yeah, of course, we are primarily dealing with a specific CFD code called SRH2D, which is a reclamation model, and it is used for sedimentation and river hydraulics. That's why the name comes from. Next. Yeah, this code is primarily used for environmental flow simulation. And the code itself solves the 2D depth average equation. You can think of the Navier-Stokes equation, but it's depth average. Okay, that's why it becomes 2D. And other terms used for the equation set, sometimes called Semvina equations. Other people call it dynamic wave equations. And for some of you, if you are from the aerospace industry, then I will say this equation set is very, very, very similar, almost the same as the 2D compressible flow equations. Okay, so in the hydraulic, we call the subcritical, supercritical, and transcritical flow. But correspondingly, in the aerospace, we call it, subsonic, supersonic, transonic flow. So that's the background. And yeah, this model has been documented in papers and in manuals. And for some of you, you really want to see the equations, and here's the equations. Yeah. And so I'm not going to explain these equations. As you can see, it's very, very similar to Navier-Stokes equations or the 2D, compressible flow equations. Okay, next. And this model itself, besides flow simulation, it has a very important component called simulating the sediment transport. But as far as the equations goes, we are just solving a bunch of additional partial differential equations, and each equation is a convection division type. So it's really not much different from the momentum equations in terms of a numerical solution of it. And the sediment transport itself also have been documented, and in case some of you would like to know more details. The unique feature about this code is the kind of a mesh it uses. So, for example, we use the hybrid mesh, like the left figure shows. Usually, it's a combination of quadrilateral and triangular mesh. And also for some other problems, this code also deal with local refinement mesh, like the right figure shows. The reason I want to mention this is because of this flexible mesh use, ultimately the matrix, because the solver is implicit. So the matrix itself is not, the bandwidth is not a constant. The bandwidth is variable. So that makes the matrix solver, a little bit more complex than the other approach, like the structural grid. For those mesh, the matrix is banded, symmetric, but this is not. Next. Then what's the challenge here? This model has been widely used for environmental simulations, usually for environmental problems the spatial size is big. For example, we may simulate more than 100 miles of a river. And also time scale issue. We may need to simulate multiple years of flow. So because of this large scale issue, runtime is too long. That's the purpose of this price change. We want to cut short the runtime. Next. So the solution, of course, is parallelization of this model, either using multi-core technology or use GPU. Next. But when we try to make the code parallelized, then there are challenges here, two challenges basically. The first challenge is the linear equation solver itself. Because this linear equation solver is implicit, right? And also this linear equation solver, in order to be stable, we have to use, so two challenges. First, this solver has to be very stable because you have to be able to solve the problem first. Then next challenge is how to parallelize it. Why it is important? Because the linear equation solver is more than 50% of the entire runtime of the model. So if this linear equation solver can be parallelized efficiently, then we already solve more than 50% of the problem. Yeah. Next. The other challenge, of course, is the code itself. Even if the linear equation solver has been parallelized, works efficiently, but the code itself also needs to be parallelized. That's why we divide this competition into two phases. Phase one, it has to be demonstrated. You have a good linear equation solver that meets two important criteria. One is it's stable, capable of solving tough matrix. Then next, the solver is highly parallelizable. Once phase one is successful, then we can move on phase two, which is to parallelize SRH 2D itself. Okay. And in the past, at Reclamation, we indeed has made some effort to make SRH 2D parallel. For example, we have tried the MPI-based domain decomposition method. Okay. We achieved some success, but it's limited. The limitation is the speed up itself. We find out when the number of cores increase more than 16 cores, the speed up starts to flat out. Okay. The second challenge is domain decomposition itself. Right now, as it was implemented in SRH 2D, the usage is not easy. Okay. We want to make the model easy to use for other, because a lot of engineers are using it. Okay. So two issues. Next. Next. Yeah, so in terms of the expected outcome for phase two, okay, we want ultimately to, we have a SRH 2D, a version of SRH 2D, which is parallelized. In terms of the speed up, the goal we want to achieve is at least we can achieve 10 to 20 times faster if the code is running on a 32-core PC. By the way, this competition will limit the parallelization effort to desktop PCs only. We are not talking about massively parallel here. Okay? So the requirements include use the newly developed parallelized linear equation solver, put it into SRH 2D, then SRH 2D code itself should be parallelized using OpenMP, MPI, or GPU. It's up to you. Okay. And also, the parallel run itself should be easy to use. That's the purpose. So in terms of the data set, the benchmark data set we use, I will turn this to actually Ben to share with you what we did here.
Thanks, Young. Hello, everyone. So we're just switching gears here. What I'll be talking about, just providing a brief description of the data set that all registered competitors will receive to provide some guidance to make it a little bit easier on you as you navigate through the material. So all competitors will receive 2 data sets that we'll use to assess their solver performance. And so the package that we provide will contain 3 folders, a code folder and then 2 dataset folders. The code folder that we provide contains an executable that will run the current solver that we use in SRH. And so you can run that executable and it will run our solver for the datasets that we provided. And then within that folder, we also provide a source code for benchmarking your source code. So in the source code, there's a place where you can put your solver in, and then what that source code will do is it will read the data sets from the files that we provide and set the A matrix and B vectors for you to then solve for X. And then the source code will tell you how long your solver took to solve the problem, and also calculate the absolute mean error of your solution. So within the datasets folder, each folder you'll find a file called matrix.dat. And what that file essentially has, it just contains information on the A matrix that you'll need to solve the linear equation. The source code that we provide actually sets up, it'll read the A matrix and then set up the B vector for you, and then your solver can proceed with the solution. Now the matrix, the information in matrix.dat is stored in the, like, using the data structure that we employ in SRH. I'll briefly talk about that next, but then also within the package, we provide a Word document that describes everything in that, in that data set, in that package that we have. So if you have any questions or the things that you need answers to, I would recommend going through that document. And if you still have any questions, please feel free to reach out to us. Next slide. So just a little bit about the data structure that we use in SRH. Like I said, the source code that we provided, which is in solve matrix .f90, will read the matrix file for you, so you don't have to bother about that. But then it saves the A matrix in 2 different arrays. So we have a separate array for the diagonal elements of the matrix, which is the AP array you'll see in the source code. And then for the up diagonal non-zero elements, you store that in the ACOF array. AP is straightforward. I won't spend too much time on that. But in the ACOF array, there are a couple of things that you need to note. And that the values stored in the ACOF array is actually stored with an opposite sign. So if you have an up diagonal element in the A matrix that's, for example, -2, then in the ACOF array, it's actually stored as +2. That's very important, so it's something worth noting. Other than that, the ACOF array is stored in standard compressed parse row format. And that, so we store just the non-zero elements. We start with row 1 and then store row 2, row 3 consecutively that way. Since we're not storing the 0 elements, we also have a separate array that stores the column indices corresponding to the up diagonal elements. And I mean, if you're familiar with the CSR format, you know that row access is easy, but column access is not so straightforward. Next slide, please. So this is just basically describing what I just went through. Of diagonal elements, the diagonal elements in red. So you see AP matrix. You have them consecutively going down the row, and then you have the off diagonal elements starting the ACOF, where you start with row 1. You saw the elements, the non-zero elements in row 1, and then row 2, row 3 consecutively. Next slide, please. So this is my last slide, and this is sort of just to help you out. I mean, how you would access elements of the of diagonal array. So if you want to access the elements on a particular row, you need to access the row pointer. And the names of the variables are provided in this slide, actually the same variables that you'll see in the source code. So say, for example, you want to access elements in row 3. So you have to call the row pointer LCLSC1 3 at index 3, and then it's going to return an index 6. Now that value 6, or that index 6 that returns is the index in the of diagonal element ACOF, where that row starts in that of diagonal array. So you get 6, and then you call ACOF element at 6, and then it takes you to 3, which is the first element of that row, and then you can just simply iterate through to get the other elements. And as I said, we also store the since we don't know since we don't save the 0 elements, we store the corresponding column indices as well, which are the LCLSC3, which are the LCLSC3 array. Hopefully this is straightforward, but if you have any questions, we'll address those to you. I think that brings me to the end of my session. I'll hand it back over to you.
Perfect. Thank you both, Young and Ben. So like Ben said, if you have any questions, make sure to use the Q&A panel for your questions, and we'll get to your questions at the end here. So a couple of other things that I want to discuss with you guys. So starting with the challenge timeline. So to start off, the first phase of the challenge has launched and is currently live right now as of September 8th, 2021. This means that you will be able to access the challenge link through freelancer.com, add comments and questions to the public clarifications board. Now, once you are ready to submit your entry, you have until March 27th, 2022 at 11:59 p.m. Eastern time to submit your entry. Judging for phase 1 will occur between March 28th and May 10th, 2022, with phase 1 award announcements on May 11th, 2022. On May 11th, phase 2 will launch, and you will have, on May 18th, 2022, phase 2 will launch, and you will have until January 15th, 2023 at 11:59 p.m. Eastern time to submit. Judging for phase 2 will occur between January 16th and March 22nd, 2023, with the final awards for phase 2 announced on March 23rd, 2023. So here's how you can participate. And we have simplified this into an infographic for you. So step 1 will be to create an account on freelancer.com. As we mentioned earlier, you will need an account on freelancer.com to be able to submit your entries. So make sure that you create one as soon as possible. Step 2, read the challenge brief, read the full challenge brief, right? There's a link on the challenge page where you'll see the full version of the challenge brief. There's a lot of information for you in that brief. So make sure you read that in full to ensure that you're eligible to participate. Step 3, ask questions. There's a public clarifications board on freelancer.com for you to ask questions. So make sure that you make use of that. Step 4, an important one, is to register. So there's a link for you in the challenge brief to do that. Step 5, work on your entry after your registration is approved and you receive the data sets. And step 6, submit your entry by the submission deadline. Now, I can't stress this enough. Do not wait till the very last minute to submit your entry. For one, if you submit your entry within a reasonable time before the deadline, freelancer.com can help you ensure that your entry is complete. Additionally, you may be required to update your profile on freelancer.com before you can submit your entry. So don't leave it to the very last minute, because you won't have time to be able to submit your entry if you have to go through those other steps. So get your entries in on time. Okay, lastly, before we get to the live Q&A, here's a quick summary on eligibility. Okay, so for one, all team members must meet freelancer.com's eligibility policies, freelancer.com's terms and conditions, and freelancer.com's copyright infringement policy. Next, all team members must be at least 18 years old and must be eligible to receive payment under the laws of the United States. United States federal sanctions prohibits participation from individuals and teams from certain countries. Bureau of Reclamation and employees of challenge partners are not eligible to participate. Federal employees acting within the scope of their employment are not eligible to participate. Any individual or entity associated with the development or administration of this challenge is ineligible to compete. Government contractors working on the same or similar projects are also ineligible to participate in the challenge. And lastly, funds from US or foreign government organizations should not be used to directly fund the development of a solution to this challenge. Solutions that were previously developed with government federal funds or where government federal funds, including but not limiting to employee time, materials, and reviews, were utilized to prepare the submissions or solutions are prohibited. Okay, so let's dive into some of the Q&A section of this webinar. So reminder, once again, use the Q&A panel, don't use the chat. We will only be looking at the Q&A panel for your questions. And to kick things off, we do have some prepared questions. So I'll go through these first while you guys are typing out your questions and thinking about your questions for Young and Ben. So first off, is it free to join this competition? And absolutely it is. It is free to both sign up and participate on freelancer.com as well as register for this challenge. Can anyone join a team after its registration? I'm trying to find teammates, but I want to fill the registration form in order to get data sooner. If you are the team lead, you can add more team members to the team after you register. If you add new team members, you just need to make sure that you submit a new registration form with the updated information, okay? If you instead want to join a team as a member, not the team lead is the one that's going to be responsible for submitting the registration form. Can I participate from XYZ country? So we got a lot of questions regarding specific countries. And the key here is to check the link that we have in the challenge brief for you. So we've set that link and check that link first. Once again, read through the entire challenge brief. If the country, if your country is not eligible, you cannot participate as an individual, but you can collaborate with the team whose team lead is from a designated country or the US, okay? Two other rules still apply, right? Submissions must still originate from either the US or designated country or have been substantially transformed in the US or designated country prior to delivery pursuant to FAR 25-443C. Also, check that link to ensure that your country is not under any of the country-specific sanctions. Okay, one more here before we go over to a live question. As an employee of a state university with part of the work considered to be supported by the New York State government through salary, am I still eligible for the competition? The answer is yes. The eligibility requirement is referring to funding sources from the US federal government or foreign government organizations. Okay, so let's go over to a live question. So I saw a few questions that have been answered, but let's go through those again, just to ensure that everybody had a chance to actually review those. So first off, is the current LES serial? Young, do you want to answer that question?
Yes, the answer is the current linear equation solver within SRH2D is a serial. It's not a parallelize.
Perfect. Another one for you, Young. So can I write the solver in C, C++, and provide appropriate linking with Fortran interface?
Yeah, my answer to that is the solver written in Fortran is preferred, although we are not 100% ruling out the other approach described here, but Fortran will be given priority.
Perfect. And have you thought of using latest Boltzmann method instead of an NS-based solver?
The answer to that is for this competition, we stick to the current technology already in SRH2D. So the answer is no.
Okay, well, let's switch over to Ben. So a question for Ben. Can we use OpenCL for both CPU and GPU-based technology, or do we have to use OpenMPI for CPU and OpenCL for GPU tech?
I think, so to follow up with what Young said, yes, you can use OpenCL for CPU and GPU, but you must provide a Fortran interface. If you have any CPU code, though, we probably will provide reference to Fortran code, as depend on how your code is structured.
Perfect, thank you. And I saw a couple questions early on regarding the recording. So yes, there will be a recording and that will be sent out to everybody who has registered. And so along with that, the recording will obviously show the slides. Okay, so let's go back to some of the prepared questions that we have. So we have one here. If I register for this competition as an employee of the university, will the prize be awarded to the university or to the team members, or will it be up to the negotiation between the university and the team? So your relationship with your university and how this competition fits within your employment requirements is between you and your university. So make sure that you guys complete the negotiations with your employer. Next up, how do you download the data sets for this challenge? Okay, so going back to that infographic, you must first register and follow the guidelines in the challenge brief. And once your registration is approved and deemed eligible, the challenge team will confirm your registration and send you that download link. Okay, let's go back to some live questions here. So take a look here. So for Young, what's the expected speed up of? What's the expected speed up for phase 1? Young, do you want to answer that?
Yes, and actually there's no difference between phase 1 and phase 2. So for me, it means for phase 1, we are looking at least 10 to 20 times speed up for the linear equation solver when it's run on multi-core PC up to 32-core PC.
Okay, perfect. And is there a requirement for specific Fortran version or compiler? Young, do you want to answer that?
No, actually, we don't. We don't have requirement, but when you submit the performance of different solvers, you have to use exactly the same compiler.
Okay, perfect. So we have a question in the chat. Once again, guys, try to use the Q&A panel, but a question here in the chat regarding to eligibility criteria. Is it possible for a team lead from a non-designated country to lead a team with mixed members from designated and non-designated countries? Jen, do you want to take that?
You bet. You bet. So if your team lead is eligible under the criteria or the requirements in the rules under that, I think it's the Treasury listing. If your team lead is eligible from there, you can lead a team of mixed countries. And I think there's an answer in the clarification board on that too, to help with that.
Perfect. So let's go back to some prepared questions that we have. Okay, so I want to check if you can also provide the coordinate file for the underlying mesh. I can generate a much better partition for my solver if the coordinates for the mesh are available. Young, Ben, do you guys want to take that question?
Yeah, I think our answer to that is the mesh is not going to be sent out as part of the database. And however, if you think you can rearrange the matrix format based on the mesh, we encourage you to do so with your own data set and then submit the results, which we will consider in judging.
Mhm.
Perfect. Another question here, can a company participate? Jen, do you want to answer that?
You bet. So companies are welcome to participate. I would encourage anyone that is associated with a company to work with their ethics and their legal and work through the rules in the competition associated with the licensing and with the designation. So read those closely, work with your legal, work with your ethics if you have that, to ensure that you would be able to meet all the requirements.
Okay, another question for Yong and Ben. Would a Dell Inspiron 11 3000 series laptop be appropriate for this challenge?
I can answer that. Well, whatever PC you use is fine. You should just be able to demonstrate the speed up to 16 or 32 cores, and that's pretty much what we want. So long as you use a machine that can demonstrate your speed up to the maximum number of cores we're looking for, you're fine.
Perfect. So last chance here for any live questions for Yong, Ben, and Jen. Keep in mind that we will share some of the answers and questions that were asked during this webinar also in the FAQs document. So make sure of that. Okay, so we have a question here. The team leader must a team leader live in a designated country? Or if the team leader was born in the designated country but lives in a non-designated country, is that okay? So once again, does a team leader have to live in a designated country, or if they were born in the designated country but live not in the designated country, is that okay?
I can answer that, David, kind of. I think this is a good one for us to go back and provide some clarification on that, the board. One thing I think is important to look at is going into that rule or that regulation. I personally don't know if it says reside in or is a resident of. So I think there's some distinction there that solvers can look into, but we can also maybe find that language and post direct solvers to that section of it.
Perfect. Another question here, can a Windows instance from a cloud provider be used? Yong, Ben, do you want to answer that?
Ben, can you?
Yeah, I mean, it's since you can build a Windows instance with different cores. I think it should be fine. Yeah. But again, limited to the number of cores that we're looking for. The only thing I would say is the cloud provider might actually create virtual cores, so that might be something that the competitor would want to look into.
Perfect. So any last questions? We'll give a few seconds here for a last minute question. I did see a hand up. So once again, if you have a question with your hand up, make sure you pop it into the Q&A. Going once, going twice. Okay, well, thank you so much for everybody who came on to the webinar today. We hope this was helpful for you guys, and good luck. And we look forward to seeing your entries. Thank you so much.